Hey, good morning everyone. Another advent of code. Hope this time shorter one. It's Friday, maybe something easy. Okay. We have some rope bridge. Let's just twist. Maybe you can even figure out where not to step. The tile. Okay. 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 Where the tile goes as the assume the start head and tile will start at the same position. I assume raft up, left, down. And this is, I assume, the distance, right? F. Okay. Starting position, so 4, up 4. Let me see this. Okay, head goes here and tail doesn't move. Okay. Okay. Down one, okay. Seems reasonable. After letting the rope, you can count up all the positions of tail. Visited and okay. I just need to say this is program is okay. So basically, this is kind of simulating. Okay, so I just got the steps here. So no passing today, hopefully. Wondering where is my start? Always bottom lower corner. There was something about this. I think that was the point. Okay. We just need to work out it. So that's the thing that I am not exactly sure if it can be assumed to be the lowest left corner. Maybe it was something there, but I just don't see this information. It's my input. It's simple enough. Kind of the problem is that if I would just use the plane, I might go into negative indices, which I would prefer to avoid. I could always trying to figure out what is the best method to go with here. Oh, this would help. I'm going to be lazy again. I would create the enumeration so I can easily match on that later. And then okay, I asked them to fit in that size because I might want to go with maybe in Q size. Because I will use this in arithmetics for indices, and indices are U size. That's why I picked U size over U to avoid Zigbee. And then I go for lines, and then I would map filter map my lines. And then I would map my lines. Okay. And then I would collect those guys. And how do I map it? Parts. On spaces, right? Yeah. Direction, which is this. I will just filter out white lines. Today, try not to be fancy. Being honest, just that. Can I use question mark with option? I think I can. I can. So question mark with option just forward, pushes forward the known, and it gives me the sum variant. And then I want distance, and then I do okay direction dance. What happens here? So obviously, so it's my input. Check if it works. Where is my test input? No, I'm using kind of wrong command. Run. Okay, that seems legit. What do I need? I don't want to, I could draw it in some array, but I don't want to go negative. I also don't want to keep all the possibilities. I might collect the path easily. This is something I can do very easily. Just collect the path into the vector, like in this list, and I might not care going negative there. So my move would be I32, just because I would like to use I 128 for consistency with previous things, and I 1 to 8 would be my index. I would have vector pair of visited fields, and then I would sort it, dedup it, and count it. And I find the solution as being the simplest. I am not sure if it is the simplest, but I am going with that. It should be fairly okay. So, and I would start on 0, 0, obviously. Sorry. And part 1 is a slice of moves. I got U size right. What is the how many positions? How many positions is basically U size, because I would just have size of my vector, of my sorted vector. Sorry. I'm wondering if just collecting those guys to hash set wouldn't be simple, wouldn't be faster, but hashing is. I mean, why I'm thinking about that instead of just use it, because I just like to do things properly. And what is the difference? Let me explain quickly. So I could use vector and just, build a vector of positions like 0, 0, then let's say 1, 0, then let's say 2, 0. I mean, I build a list of position, but then, for example, could go back for some reason, like this, for example. And now, I would need to deduplicate this, but to properly deduplicate this, I need to first sort this. So why it's good? Because adding to this kind of vector is very, very fast, and this basically helps the fact that it is very fast. But there is a problem that I need to sort them, which is n again is sorting, and then I need to do another thing, deduplicate, which is n. So I basically, it's something which is this complicated. While if I would use hash set, I would always have just a set of those positions. And what is the advantage? The advantage is that I never need to sort it or anything. I just need to calculate the length of it. But there is a downside of this, and the downside is that every time I push something to the hash set, I need to calculate its hash, which is time consuming. And yeah, but we'll not get crazy. Normally, if I would really need be performant, I would just implement both solutions and pair the measure performance for it for both cases and pick the fastest one. So the vector solution is for sure. Is it for sure faster? I don't know. For lower data sets, I don't know. Doesn't matter. I would use a hash set. So let positions is hash set. Let him deduce the type of hash set, and I would go like this: input eta. I would fold it. Basically, every next position is kind of a fold. So what would be in my fold. In my fold, I will not fold it, I will scan it. Alright, stood like that. Because fold like collapses to single value. I want to have iterator. And so I think I need to scan, give me my scan. Scan has state, except my state is mutable, and I return next values from the vector, and this is what I actually need. So I need scan. Too big. So I would just do this if I would need my browser. So in scan, I need two things. I need in my state. First, I need position of my head, and then I need position of my tail. Because I mean my position of tail depends on position of head, but I can only actually calculate position of head directly. And this is my state, and here I can deconstruct the state. So let's assume first is tail. So tail x, tail y, then head x, head y, and the other one is just direction distance. Except what I have here, this scan would return me. Every iteration is set of my indices, because direction might be bigger than 0. So I would collect this, and this is, and here I would just go with position dot plan. This is what I want to do. The tree format, it doesn't know what to collect to, which makes sense. So first we want to advance the head in some direction. So first of all, we would always have here kind of, I want you to return vector, another vector. Let me think about. First, let me think about the single step. So I need a function. Let's call it advance. I would take x, y. It's I guess. Yeah, because it can go negative. And I need direction. And I want my new pair of x, y. Up, I go y up. It seems reasonable. And now I want my new head's position. I want my new head's tails positions. Iterator of them. But I also have to modify those guys properly. And because I know this is mutable, I can go with all them. Oh, this whole state is a mutable borrow, right? So I guess I can do this. I just want to make sure that all of this properly work. So I will go telling it that this is just this, because I would collect you only. It's like this. What is the type of this guy? Okay, that's already Mutable borrow. This is what I wanted to know. So now it repeat with. But I don't want repeat. Or I want. And now I go with function here. And my function is let I would update tab fast. This is not trivial. So I would like to call flatten here because my scan is returning the iterator, right? So I really want to flatten it later. Those guys might not live long enough. Yeah, it makes total sense. Because I want to simplify this. I obviously know that it's advanced ones, first of all. This is just to calculate those guys. I would call advanced. This is the same. Advanced and this. So why I do this? I want advance here. I advance it by 1. What I do here, I would do a little bit of a trick here. So I would say that think is if I can do this way, because I still need. I try to avoid some random relocations. I would like to do it very lazy, but no, I will not do this very lazy. I would just go cheat and I need to take how many? This, which makes sense. And then I need to collect them into the vector. Because why it was not happy is that Okay. Go. It was complaining because it was not running this whole iterator unless the collect is called and this ty hx could be, you know, not alive anymore. But if I collect it, I enforce the Rust to like go through this whole iteration on this very step of scan. If this makes sense. So this is what I do here, and then I need to. Why advanced is never used? Because this is part 1 is never used. It doesn't matter. Fn. I would call it just tail. So I have tailx. And I want new. This is this exactly what I want? If that is equal to. No, it is not exactly what I want. So my new x is, what is my new x? If Ex is equal to hx, right? Then it's tx. Else, if tx is lower than hx, it's, yeah, this is exactly what I wanted. The other one was like always updating the one coordinate, but here I might need to increase both. The whole thing here is just if also not exactly if my coordinate, what's if my coordinate is different by mode, because it is not exactly true. Let me read this rules exactly, because I wanted to simplify. Where it goes in this case, yeah, that's important that in this case it goes here, even though here is also a proper proposition. But if the head and tail aren't touching, the slate moves one step diagonally to keep it. So it's like this. If this, can I call ABS? I can. Is most one, and the same is on the Y. It is just this guy, right? So this is the only case when my tail is not moving if I am at most one step away in all the directions. Now, else, if I don't want to change my this this coordinate, now one coordinate stays the same. What is y? Y is this. Else if ty. And in any other case, no matter what is the distance difference, I just want to move one step in both directions. Okay, this should be the proper thing. So tail x, tail y, it's tail of this. And now I need to return the tail position. Tail is what is interesting here. Those I need to just update because the state is mutable itself, and it should probably work here. Collect it to vector. I think I could do it a bit smarter without collection by calculating the final position of tail with some even with this algorithm. I could calculate it with this algorithm, but I would need to run this algorithm twice, which once not collecting in anywhere, and then just iterating. The problem is that could be more efficient because I would not collect it in the mid time. But yeah, there probably is the easier solution because I go up. I could probably figure out on the very first move what would be the better position, but it would be good enough for this puzzle, and it's simple. This is important. It's less probable that we would make a mistake if the solution is simple. So that's why I like this solution. And what I want to do, I want to do this first. For this test example, I really want to see my positions. And I won't even go with this. I first want to see positions collected into the vector. I know I want to go to hashset later to remove duplicates, but I want to see my path. Because it's the thing that debug pretty prints. I don't want pretty print in this very situation. I just want my debug print. If you want print in pretty way, you can always do this. Yeah. This is the pretty print, but I actually want the simple print. So now I want to go with this alignment. Okay. Okay. 0 0 1 0 2 0 2 0 3 0. It stays 3 0, goes 4 1, goes 4 2, 4 3, 4 3, 3 4, 2 4, 2 4. It stays on this 2 4, then it goes to 3 3, which is, I guess, this one. It looks kind of proper. Let me check the. I don't want the typing hashset. It should already be able to figure it out. Please show me the result. 13. 13. Okay, it seems to be okay. hopefully I give proper Firmcast an answer. That's good. Oh, the rope snaps. Suddenly the river is getting a lot closer than you remember, and bridge is still there. But some ropes, blah blah blah. Okay, see what happens. So every, I think I see. Wait. One goes here and more types of motion are possible. So you might want to visually compare your simulated rope to the one above. 1, 2, 4. Oh, take one. You get what happens. It's up to 9. Because yeah, I simulate up to 9 motions. And every next is like goes like after tail, like no. Okay, now 9 visits. How many positions does the tail is 9, right? Because but they're not marked. Yeah, new tail 9. That is simple. So this is basically the same as the first, except I need to. I mean, my thing is my scan here would be a touch more complicated. So I need to try head, and then I guess 9 or 10. I mean, it's one base, so then 9, H is 0. So I need to track of 9 knots. So my state would change a bit, and it would be it would be 0, 0, but 10 times. Well, index 0 of this array is my 0 knot, my head, and the other indices are other knots, so they would follow it. I obviously need to change this guy to okay, I don't want this to rope. This is just my rope. This is 10 elements array. And now I first need to advance my head. And my head is my rope 0, not 0. My y is my rope 0. This is how I address my tuples. And I add y. Yeah, this integer because and here I have my 0, 1, rope 0, 1, in my direction 1 step, always 1 step. Yeah, this advance actually doesn't need this argument. I would get rid of that. I thought it would be useful, but it won't be. So I want, if I would try to do this shortcut with calculating it at once and then somehow adding the whole chain, it would be useful, but yeah, I don't want to overcomplicate the solution. And now what I need is I need to go with all my whole row. I want to do this like nicely. So I would have next, and I would go like next x, next y, previous x, previous y. I would have those pairs in oh, I cannot do that. I wanted to zip the rope with itself, having like the second one of those borrows mutable, but I cannot do that because why? Because I cannot borrow mutably and not mutable one the rope RI ones, but I'm wondering about Windows here, Windows mute. Let me quickly check this Windows thing. Slice from that. I could go with index also, and I might do that, but let me quickly check Windows. Those windows are slices. Yeah, windows are just slices. And those are pairs, so I could go with slice the constructions. No, slice the constructions will not work here because it works for matches, but I might have invalid pattern, I assume. For pair in rope Windows 2 exactly this way, and the 0 would be previous, the 1 would be next. So it was like let's x y. Oh, everything here is copy, I guess. So I guess I can go with I want to calculate next. Tail, what was the arguments for pair? It was a tail. Now, first I give him tail, and this is my tail, right? Yeah, and then I give it the previous guy. So I basically go through the whole chain, updating the second argument of this slice of this window. So the second argument like follows the first one. And then I need to return my new position of my last knot, right? So it's rope 9. It's just rope 9. Windows mute. Really, there is nothing like Windows mute? It really doesn't make sense. Yeah, our Windows is kind of nice. Wow, there is nothing like... So, because there's nothing like Windows mute, we will be very lazy here. Mm. I will just go with indices. And it would be rope index. I'm disgusted that there is no Windows mute. They don't understand why, because it would guarantee me that I use only one of those. I mean, even if I mean, it's guaranteed that my slice is not borrowed anywhere else, and both elements are not overlapping, or anything. I don't know why it's done this way. There's probably a reason I just cannot figure out right now. And here I want to go with previous. It should be optimized anyway. Yeah, I don't want those brackets. I kind of don't like this repeating, but I don't think there's any better way than just scan to figure out positions. So let's not care. What result I expect here? 1. Yeah, 1 was for the very first. And you need to keep track. Larger example. I would use the larger example. Maybe I would have some 7. What is the proper answer? It's not proper answer. Did I copy the whole thing? I would like to avoid drawing this, honestly. So let's start thinking about it, because maybe the mistake is kind of obvious. Sometimes it happens. I advance the 0. I do this distance times for this guy. Every one of these guys. This is my distances. Then I go with next. This one I don't like. It's obvious typo. And this might be easily the problem. 36, and yeah, I mean, having this as a proper right now would be very improbable, if it would not be a proper answer. And it was a proper solution. Yeah, I don't like this smooth table thing here, but this is how scan works in Rust. I might prefer different solution, but it doesn't really matter. It's kind of simple. It could be probably a bit simplified or something, but yeah, this is it. Thank you for watching and see ya tomorrow. Bye.